Hello, everybody. In this video, we're gonna talk about one new feature in Aspen Plus, which is pretty helpful in many cases, like the case that we are gonna talk about today. So this is the calculator option, which is here in the flow sheeting options. We have design specs and the calculator. And this calculator option is kind of similar to the design spec in some sense, but its function is kind of different. So to understand what the calculator does, let's quickly revise what the design spec does. So the design spec, like in this case, when we were doing the absorption column, we chose or we asked the design spec to change the flow rate of the solvent so that the flow rate of the ammonia coming in the airstream does not exceed 5 kilomoles per hour. So what it does, it simply changes the values of uh, the manipulated variable that I have here, and between two values that I specify in the design spec, and it calculates the flow rate of the solvent or the ammonia, which is the calculated variable that I'm interested in, and by changing the values many times, it can reach a value that satisfies the condition that I want to satisfy. So this is simply the function of the design spec, and from this we can see that it's kind of a process that does a lot of calculations. It kind of consumes some time because it's doing a lot of calculations. It may go for like 100 calculations so that it can reach the desired one. And we saw some cases where the design spec was not an option. Like when we were doing recycling, we had to use the design spec so that the flow sheet keeps going the way it should go. Like when we did the recycle here, and to put the flow rate that will keep the two units working efficiently without having any problems. So this is simply what we did regarding the design spec. The calculator is kind of similar in the sense of relating two parameters together, but from its name we can predict what it does. So it calculates one variable from the other. It's not changing one variable to satisfy a condition, it is calculating something from something else. And to have like a feeling of the difference, we will do the same thing, or we will apply the calculator on this block. But before we talk about this, there was something that is kind of related to what we're going to talk about today, but we didn't mention before, which is related to the displaying the whatever we have on the flow sheet. So we mentioned before that you can display the temperature, you can display the pressure, the flow rate, and we saw that before. But there is one other option here, which is in the display option. You can choose to hide the IDs of the streams, which is something that I do not recommend at all, because you need to know which stream is this. You can hide global data like the activated design spec that I have here, and you can display we'll say this calculator connection like in few minutes, but there is something that you can display, which is the design spec. So the design spec can be displayed as a block, like the all the blocks that we have, and we can display the calculators as well. So this is something that's kind of nice. And the other nice thing is that you don't need to go here to create a design spec. You can get it from here. So we can get it from here, and we can get the calculator from here as well. So I'm gonna create a calculator. See, the calculator folder is empty now. Now it's not empty because I created a calculator. So you can do this by going inside and create a new calculator, but you can do it from here as well. Um, so what I'm gonna do is kind of similar to what we did before regarding the calculation of the solvent flow rate. But what we do in reality is that we calculate the solvent flow rate based on the minimum solvent flow rate. So we know that the minimum solvent flow rate is like, say, one or it's equal to the feed flow rate. So this is the minimum, which will achieve no mass transfer. So we use like 1.2 times the minimum, so that we can have like reasonable number of stages to achieve what we want to achieve. So what I'm going to do now is to calculate the solvent flow rate from the feed flow rate, so that it's 1.2 times the feed flow rate. Let's say this is what we're going to do. And this has nothing to do with the ammonia that's coming out. Of course, it's going to affect it, but I'm not calculating the flow rate based on the amount of ammonia that's going to come out. So this is the one, like the big difference between the calculator and the design spec, is how you tell it what to do. You tell the design spec to change the solvent to achieve a goal, but in the calculator you ask you tell the software to calculate this from this, regardless the output. So you don't think about the outputs here. So I'm gonna call it the water flow rate. And before we open the calculator, let's think what we're gonna do. So first we need to, what my sense says, that I need to define the two variables that are gonna be included, and I need to tell the software which one is gonna be calculated from the other, and I need to define the equation that is going to or that I'm gonna use to calculate the solvent flow rate. So this is like roughly, or the rough estimation or rough prediction of the inputs that I need to define. So let's see what we have here. So this part of the define is pretty much like what we have in the design spec. So I need to define two variables: the gas flow rate and the water flow rate. And let's go, this is a stream, and then a stream variable, and this is the stream, is the gas, is the feed gas, and then the variable is the mole flow in kilomoles per hour. Now let's go to the second, which is a stream variable as well, which is here the solvent to absorber. The variable is the mole flow and in kilomoles per hour. So now these are the two variables. Of course, you can include like 10 variables if you need to use them, but in our case, it's a simple case just for the sake of demonstration. And these are the two variables that I want to define. There is one more thing that we need to define, but I'm gonna keep it for a few minutes, or a few, like maybe less than minutes. Here in this calculate tab is where we write our equation. So what I'm gonna do is I'm gonna display the variables list, and I'm gonna ask it to calculate the water flow rate to be equals 1.2 multiplied by the gas flow rate. So this is simply what I want to do. It's just calculating this from this. Still, I need to do one more thing so that I can tell the software that this is a value that's going to be imported from the software, and this is a value that is going to be exported to the software. So this is the new input. I have already the input here for the I don't know, where was it, the solvent flow rate. It is 910. So I have it 910, but it should be less than or more than that. It should be 1 or 1200, because this is 100. One nice thing about the calculator is that it creates these connections, which are the calculator connections here. These connections are very helpful because they can give you a visual understanding of the parameters that are connected using the calculator. So you can easily now tell that this and this are related by the calculator. It's not telling exactly which one is calculated from the other, but it's giving you a sense of which streams or which variables are related. So now let's go back here. I need to tell the software that this is gonna be imported and this is gonna be exported, and this is what we can find here in this information flow. You can either get it from here to make the gas flow as the imported variable. So this is gonna change automatically here, and you can make it as exported variable, which is gonna reflect here as well. I'm not sure why they have it in the same place in two different parts, but this is how it works. You can choose it either from here or there. Um, and now let's go for the last part, which is the sequence, which you can pick where uh, or when the calculator is going to work. You can choose to get it to work in the very beginning before doing anything. It's calculating the stream and then going to the simulation, which is going to be our case because I don't want it to calculate the flow rate after running the simulation. This is the flow rate that I'm going to use for the solution of the absorber. Or you can do this as a last step in case you want to calculate something after the run is done, or before a specific unit where you can now, let's say I have a unit operation or equipment for instance, and then I don't have equipment here. All these are considered unit operations, so you can choose to do this before the absorber, or this is going to be helpful because in case you have like units preceding the absorber and the gas flow rate is dependent on the preceding units, then you have to make you choose this option to be before the absorber. So after the unit that are done before the absorber that are producing the gas flow rate or the gas stream, you can use the output from these to do the calculation and then run the absorption. So this is one nice thing about the calculator because it's a big difference or a big advantage that's not in the design spec. In the design spec, you have no option. You cannot choose when the design spec is going to work. You run the simulation and it's done after this, or maybe after during the simulation, whatever the process is going, but you cannot choose this. So here in my case, I'm gonna go for first, and here it's listing the imported variables, and these are the exported variables. So this should be everything that I want to define, and the inputs should be enough to run the simulation. Um, and now it is running, and results are available. So the thing that is of interest to me now is to see the result of the solution to absorber. So the input is 910 as I mentioned before, and when we go to the results we see that it's 1200. So it's using the calculator results, and you see this is one nice thing about the calculator is that it doesn't take that much time. It doesn't require like a big computational power. It doesn't require doing a lot of iterations and a lot of calculations. It's just once it's done, and now you have the number ready. So this is one very cool thing about the use of the calculator. Uh, there is one thing that you might think of, okay, so I can do this using the design spec, and I have already done this just for the sake of curiosity to see if it works. And to do this, you have to kind of do a tweak so that you can like trick the design spec to do calculation instead of doing the like iterative thing to do the or to reach a specific goal. So what I did is similar to what I did in the design spec in the calculator. I defined the two variables, and but here I asked it to change the solvent flow rate in this range, but I created a new variable which is the solvent to feed. And this solvent to feed is the solvent flow rate divided by the gas flow rate. So I want the solvent flow rate to be 1.2 times the gas flow rate. So this ratio is going to be 1.2. So this is kind of the trick that I made, is to define the solvent to feed ratio as the solvent flow rate divided by the gas flow rate. And I asked the design spec to put this solvent to feed to be 1.1 to 1.2, whatever the value that you want, and you can run it, and it should work. It should do the same thing. But there is a possibility that this does not converge quickly. I'm sorry, and that's why I think in these cases it's more wise to use the calculator because it's gonna do what you want to do with very low risk of having any problems with conversions, because it's gonna do it once and it's gonna work. The design spec has like some limitations related to the initial value that you're gonna use and the step size and different things, so that might make the conversion conversions, kind of not very thing that, or something that you are sure it's gonna happen. The conversions is questionable in this case, but in case of calculator, it's gonna be like a piece of cake, one step, and it's gonna be done. So this is all for today, and I'm gonna see you in the next video, inshallah. Goodbye.